All right, it's been a long day and I'm just about done for today, but I just was playing with these forged pistons today, setting them up. And when we get these forged pistons in, which we've been buying recently, I'll talk more about that in a second. But yeah, when they're a VN Buick V6 piston, and they've got a slightly different compression height, but they've compensated that by having more volume taken out of the crown. So they're compatible. And customers we've already set up and modified a set for a customer, and so far so good. The reports are he's very happy with them. They're working well. He was the one that actually initiated the idea of it, and I like it. So I'm doubling down here and doing it for my next customer, and if everything goes to plan, I'll continue using them. So what we've got here is, yep, as I said, it's a moly piston. Here it is here. So I got a set of 6 for the VN, and came with moly rings. We'll talk about those in a second. So to kick things off, we might just start with the weight. Right, try again. Yep, so 587, that's what I got before. And then the piston out of the current Gen 4, 588, so 1 gram, that's nothing. Oh, and yeah, so that's it. And again, it's got all the rings. It's got 1 clip missing, but gee, what does a clip weigh? So there you go. They're pretty much identical. This piston here, it's not complete, so it's not worth measuring it, but it's the same as the Gen 3. See, it's got the cutouts here. In fact, this is a Gen 3 piston, I should say. So that's a Gen 4 piston, it's a Gen 3, and that's the forged piston. Now, when we get the forged pistons in, they come with rings, but they don't have any piston pin clipped grooves, so we have to machine them in ourselves. So you can see I'll put a groove in there and I'll put a clip in, and likewise I've got a clip in there, round wire clip. You can put the square clips in, but I prefer the round wire clips. So that's what I've done with those. That's what I've been spending most of today mucking around with all this. And the piston rings I'm using are moly rings, and I'll talk about those in a second too, why we chose those. So that's a moly top ring and a CI second ring. Now CI doesn't actually stand for cast iron. It's a different. It's another material, but they work hand in hand. Well, they work well with chrome-moly balls, and I'll read some information on that in a second. But the reason I want to make this video is I am somewhat concerned about this stock Jabiru piston. Now I don't want to alarm people out there, but I am seeing a spate of. I have seen enough piston failures now at the skirt for me to know that, you know, this is something that needs to be looked at. Now I'm not saying, you know, there's probably thousands of Jabiru engines flying out there with the standard pistons, and they've been okay. But let me just show you what's going on, right? But I have seen firsthand in the workshop right here, engines coming in with broken pistons, and I've seen them myself. And when that piston fails, it's catastrophic because the conrod flays about, throws a leg out of the bed, so to speak. That's a conrod piercing the crankcase. Catastrophic failure. So, but you can see what caught my attention, and I'm sure it would catch your attention, is you see there's an oil slit here. There's an oil slot on that third ring there. See that third groove? The top ring's the compression ring, second ring, compression ring, and the third ring's the oil scraper assembly. Consists of a scraper and a spacer. But behind that assembly, deep in the groove, there's actually a slot. So there's a slot there, see? And it goes right through to the other side. And it spans right across, look, right across there. Right across, even under the skirt, under the crown, it's still going, that slot. It effectively only gives you around about 45, maybe 50 mil tops of material holding the crown to the actual piston. The rest is cut away. And I noticed that the slitting wheel that they used is square edge. Now I'm not saying Jabiru certainly didn't do this. These pistons are you know, they're proprietary piston for cars. And that slot has got a square edge on it, not even radius. So to me, it's where, well, it's absolutely where they're failing, right at the slit. So that to me is a big concern, and frankly, the way I'm sitting now, I wouldn't build another engine myself, for myself or a customer, unless he was insistent on saving money. I wouldn't put them in. Now, the forged piston's far from proven, right? There's only really one engine I know of that's under my power that I've been involved with that's flying with them, but it's going well. And I can't see why it wouldn't continue to go well. I've actually measured the diameters of the skirt and the clearances, and they're the same. And the weight's the same, so they balance out okay, particularly if you're shirtley, you'd want to use a full set. But I noticed on the Gen 3, this piston I'm holding here is a Gen 3 piston. And it's the one, as I just showed you, it's got the big slit here, see? Now that's off the Gen 3. That's the latest billet engine before they went to the Gen 4, right? So, and that's got the valve recesses and everything. So it's considered a, they're more modern piston. Now, we go to the Gen 4 piston, and lo and behold, look, those slots are gone. Where that slot was is gone. What have they got instead? They've got 4 holes. They've got one there, and 2 on the other side. See the 2 little holes there? One there, right down the bottom there, and there, and there. 4 holes. That's all they've got for draining the oil back. Now that is, and right where the slit used to be, which is about that where that lump is there, that's gone. So do you think it's a stronger piston? You bet it is. Now why do they do that? Why do they do that? Now normal VN pistons don't have that slit, right? So that's been deleted. That slit has been deleted in place of 4 holes. Considerably stronger, okay? Clearly. Now let's look at the forged piston. Look at that. There's your 4 holes. Beautiful. 1, 2, 3, 4. That's all you got. Same as the Gen 4. Now I was a little concerned that maybe doesn't give enough oil scraping or drain back. It seems to. And the customer that's been flying on them says, no problem. No problem with oil consumption. Nothing's changed in that department. So as long as these don't nip up or cause problems with the, the tolerances, which so far so good, this is the way I'm going. Now they're a lot more expensive. Set of 6, you're not going to get any change for about $1,200. But these are piston engines, right? Piston engine. The piston is clearly the crux of the whole show, isn't it? It's doing all the heavy lifting. So we don't want any piston failures. So if anything wants to be good in that engine, it needs to be the piston. Now Jabiru, of course, have had an engine, Gen 4 engine recalls, mainly due to an issue with their forged crankshaft. But let me tell you, on these, these crankshafts, there hasn't been, from my knowledge, that many failures. I know of one locally here, and I don't know of too many others. In fact, I don't know of any others. But I know of a hell of a lot of piston failures, and I would tell you right now, if these pistons were failing on the Gen 4, they'd have more recalls on pistons than they would cranks. But it seems that they've solved the issue with the piston problems because, as I said, that slit's gone. But what about the earlier engines? No recall on those, is there? So anyway, I'm just speculating. This is just my thoughts based on what I see and what I think. And this, to me, is the way I'm going from now on. Now let's talk about the piston rings. Typically, we would use a Hastings cast iron ring, just a traditional cast iron ring. But talking to a few engine builders, and even our own radials, we were convinced by the piston manufacturer to switch to moly top rings and a different material on the second ring, and we've gone that way. And I was very concerned that it mightn't be compatible with, our hard steel cylinders, chrome-moly cylinders. Same material that Jabiru used, 4340, 4140. It's in that, excuse me, it's in that material family. But it turns out, no problem. I was confusing it with chrome-moly rings, which are not compatible with hard bores. But moly rings certainly are. You can use moly rings on Nickersil, cast iron, steel, chrome-moly steel, nitrided, whatever. No problem. In fact, it's preferable. So that alleviated that concern. So I've gone and bought for this particular piston set. The first set of forged pistons I modified and sent out They had the traditional cast iron rings, but this time I've bitten the bullet and gone with a full moly ring, which is what's in there now. So that's a moly top ring. Now the moly top ring basically stands for, the moly is a surface on the outside of the ring, where it meets the cylinder, particularly on the top ring. And it has some real benefits, and I'm going to read them to you right now. All right, so here's what ChatGPT said about the use of moly rings. So my prompt was, why use so-called moly piston rings over traditional cast iron? And it says, why choose molybdenum piston rings over cast iron? Moly rings are essentially high-performance versions of cast iron rings where the top ring has a molybdenum face applied to the ring's outer surface. This moly layer dramatically changes the ring's durability, sealing behaviour and lubrication requirements. Below is the breakdown. 1. Far superior wear resistance. Is extremely hard, highly porous, holds oil, very heat resistance, self-lubricating under high load. Traditional cast iron rings rely purely on the base material. Under high temps and high cylinder pressure, cast iron loses the surface hardness and wears rapidly. Moly retains its strength and surface integrity even at 700 to 800 C. So I'm going to use the word moly from now, clearly having trouble with molybdenum. Result, longer ring life, better sealing for the entire ring life, less cylinder wear. Moly rings hold oil better due to porosity. The sprayed on moly is porous, so it traps and holds microfilm oil under pressure. Why this matters: reducing ring-to-wall friction, reduces micro-scuffing, prevents dry spots, wipeouts during lean or shock load moments, greatly reduces break-in risk. Cast iron rings are smooth and rely solely on cylinder wall oil. They have no oil retention structure of their own. 3. Much more resistant to detonation and overheating. If an engine sees high cylinder pressures, hot spots, pre-ignition, detonation, high RPM loads, cast iron rings can micro-weld to the bore, tear the cylinder plating, hone, crack, lose tension. Moly rings resist micro-welding and maintain lubrication even when temperatures spike. This is the single biggest reason all modern high-performance engines use moly-faced rings. Better ring seal, less blow-by. Now that is a seriously important issue with jabs, isn't it? Blow-by. Moly-faced ring seats faster and seals better because it conforms to cylinder wall irregularities more effectively. It doesn't glaze during break-in. It tolerates imperfect lubrication during startup. Cast iron rings often require longer break-in, perfect honing, controlled oiling, more run time before achieving full compression. Moly rings reach full seal faster, which is better for the rings and cylinders. 5. Superior for aircraft, air-cooled and high-load engines. Given your Rotec and Jabiru experience, air-cooled engines run hotter and with more temp swings than automotive engines. Moly rings handle thermal expansion better, avoid micro-scoring in hot cylinders, reduce oil consumption, maintain compression during long climbs. Cast iron rings in hot running engines can lose their seal and wear the bore prematurely. 6. Modern cylinder materials expect moly rings. Most modern bores are nickel, plasma moly, chrome-moly, plateau honed, torque plate honed. These surfaces pair perfectly with moly rings because the porosity ensures rapid bedding without scuffing. Cast iron rings can struggle to bed into harder modern cylinder surfaces. Downsides of moly rings: when not to use them. Moly rings are not ideal if you run abrasive, dirty air, agricultural aircraft, dusty fields. You have an extreme oil contamination. You have poorly honed cylinder walls. Moly can chip if installed into poorly honed. But in general aviation use, automotive builds and Rotec Jabiru projects, moly is unquestionably superior. Summary: why moly versus cast iron? Wear resistance: moly rings 5 stars. Cast iron 2 stars. Break-in speed: moly fast, cast iron, slow. Detonation resistance, sealing compression, excellent, decent. Detonation resistance, moly rings, high, poor. Heat resistance, moly, high. Cast iron, moderate. Lubrication, porosity, holds oil, relies on wall honing, the cylinder wall for lubrication. Risk of scuffing, low. Cast iron, high. Lifespan, long. Cast iron, moderate. Moly rings outperform cast iron in every performance or high heat application. Talks about some other things, and then I asked another prompt. Rotec and early Jabiru cylinders are made from chrome-moly 4140 and 4340 steels. Are these okay to use with moly rings? Yes, 4140, 4340 chrome-moly steel cylinders work extremely well with moly-faced rings, provided they are honed correctly. In fact, they are one of the best possible matches for moly rings. Below is a full technical explanation tailored for Rotec Jabiru engines. I could go on, but I think we've got the idea. I'm sold on it. Now, you do your own research. So for me right now, yeah, I'm going to pretty much be switching to moly rings ongoing, and we'll see how that pans out. All right, so you can see why I'm going to stick with moly rings from now on. I think they're only a few bucks more expensive, and I think there's some real benefits to them. So I'm going to continue to use them. So this is the first Jabiru I've actually built, this one that I'm about to build here, which is a Gen 3 3300 with these forged pistons and moly top ring. And the second ring is of a CI material, which is not cast iron. I could go into more detail on that, but I won't. But it is a compatible material, but it's not cast iron. But the top ring's doing all the heavy lifting anyway. So that's the one that gets the brunt of all the cylinder forces, combustion, detonation, harshness, etc. So there's that. One other thing too, before I finish up on these pistons, is the forged piston for the VM, which I'm holding here, has the piston pin is in the dead center. Trust me, I've measured it. It's right in the middle, right in the dead center. So there is no up or down, forward or back. Now we know from the Jabiru, some people mount them upside down, some people mount them up, around the other way, piston pin up, piston pin down, arrow facing forwards, arrow facing backwards. And none of those engines have, given any trouble doing that. Some people have their preferences, but I think a lot of it's speculative. But we don't care about that now because we're going to put it right in the middle. So if they work going that way and they also work going that way, well then we know they're going to work in the middle. So for me, this is a perfect solution. Anyway, the proof will be in the pudding. We'll build the engine and we'll run it and see how it goes, but I expect it to work pretty well. I've measured the crown and I've measured the skirts. They all check out pretty similar to the Gen 3, well not similar, actually identical to the Gen 3 piston. Another thing on the pistons is I rang Jabiru recently. I spoke with Leith, he's fantastic. Leith's always been very good to us here. And he was telling us that the Gen 4 pistons are not compatible for whatever reason, even though they measure similarly. I think there's an expansion difference, but I think the Gen 4 has probably a tighter tolerance due to the Nickel cylinders and the all aluminium assembly, so it's going to expand it at a different rate, at the same, more like the same rate of the piston. But there might be something in there anyway. So we were looking at, we were actually rang Jabiru about using the Gen 4 pistons, sorry, this one, in the customer's current build, simply because we were looking to get rid of that slit. But Leith said that they weren't recommending the Gen 4 piston for the Gen 3. So I didn't go ask him for any reasons. I thought I accepted that. So we went and got the forged piston. That was what pushed me that way anyway. So we'll see how that goes. Anyway, it's been a long video. I hope that you get something out of that. But again, Jabiru don't make these pistons. It's not really their fault, but it seems that they've got rid of the slit recently. Well, not recently, probably for a while, I'd say. Certainly all the Gen 4s I've seen don't have the slit. And those that have got the slit, most of them are fine. Like we built, tons of engines, no problem at all. But we have seen piston failures. We definitely have, and I know Jabiru have too. And I would strongly suggest that's why on their Gen 4 pistons they got rid of the slit. That's what I would have done. Anyway, there's your pistons. All right, just lastly, I'll tag on the tail end of this video. Those forged pistons are going into this particular engine. This is a Gen 3 engine, and that's the Gen 4 engine we're rebuilding. But this is a Gen 3 engine for a customer. It's going completely stripped down, the whole works. In fact, more than the works. Pistons we modified today, which is basically just putting the piston clips in, although when I say just, it's a bit of work. It's got to go in the machine to have that done, and you've got to be very accurate. So all the pins are in now with clips, which is good. So that's all done. And as you can see, the cylinder heads have been the thin-finned Gen 3 cylinder heads with the forged push rods, rocker arms, and all the valves have been seated, guides honed, seats ground, and CNC machine combustion chambers, and we've got our compression shim, which acts also as a head gasket. Now Jabirus don't need a head gasket, but trust me, these work really well. They conform perfectly and they give a perfect seal, and they transfer heat really well too. As you know, I'm a liquid cooled guy, but I do air cooled, rebuilds as well, and they need everything going for them. So yeah, all this stuff helps. And I cheat a little bit too. I actually lower the compression of the engine because it doesn't really rob you of any power. And certainly if the engine has leaking heads, which a lot of them do, in fact, just about all of them, you're better off having slightly lower compression and perfectly sealing heads than high compression and leaking heads. It's obvious, right? So that's how we go about it. Also, the slightly lower in the compression ratio also gives us a better resistance to detonation, and there's a few benefits there as well. Again, with the reduction of virtually no measurable power. That's the way we go with it, and with that combined with the forged pistons, I think is going to be a very strong combination. Yep, so all the heads have been machined, had them in the machining centre today, and they've all been redecked, so no grooves or ridges, everything perfect. So yep, this should be very strong. I've just got to, the last thing we've got to do with this engine, we've got the cylinders home, we're just putting them in the high temp paint now, and then this engine can go back together, and we'll also put the Gen 4 together at the same time. Righto, take it easy.